Okay, we need to talk about energy. Energy is an important part of physical and chemical changes. Changes in energy are, in large part, what drive changes to occur. So we have to define energy. Energy is the capacity to do work. It doesn't mean that you're doing the work, but it means that you could, or that the object could do work. So then we have to define work. Work is defined as the action of a force through a distance. So if I take this box and I push it over a couple inches, I just did work. Did I get paid extra for that? No. I pull it back. That's work. I'm exerting a force through a distance. Okay? Push the box across the floor. Pedal your bike down the street. Walk your body down the sidewalk. That is work in the scientific sense. So we decided that, or I told you, that energy is the capacity to do work. So we need to talk a little more about the energy. There are two broad categories of energy. There's kinetic energy and potential energy. There are many subcategories. We're not going to talk about all of them. Kinetic energy is associated with motion. So kinetic energy is associated with the motion of an object. Potential energy is associated with position or composition. So if we look at this illustration here, we have a 10-kilogram weight perched on the edge of the roof up here. This has high potential energy because it's lifted high above the ground. If we give that a little shove, it's going to fall down, right? It has potential energy because of its position. As it falls, it's going to pick up speed. It's going to move faster and faster and faster, and it's going to have kinetic energy. As it goes down, its potential energy decreases as it gets closer and closer to the ground. As it goes down, its kinetic energy increases because it's moving faster and faster and faster. When it crashes into the ground, personally, I like to avoid being right there up close and personal when large objects hit the ground. And probably most of you, since you're alive and mostly in one piece, have also avoided that throughout your lives. So we're not necessarily familiar with, well, what happened to all that energy? The potential energy turned into kinetic energy, but then when it hits the ground, it stopped moving, and now the potential energy is obviously much lower. What happened to the energy? It was transformed into heat energy, or thermal energy. Thermal energy is associated with the temperature of an object. Thermal energy is actually a kind of kinetic energy. Remember I said that the particles in a solid are not stationary. They don't move relative to each other, but just like you guys are all wiggling and breathing and stuff, right? If you move more, let's do that. I've always wanted to do this. Let's everybody wiggle. Just fidget and nod your head or something. Just move a little bit. Wave your hand a little bit. Did you do that? That's okay, there we go. Okay, so that's increased thermal energy. The particles are moving more. So that energy goes into heat. It causes the particles in the weight, in the ground that it hits, to vibrate more. That increases the temperature. When you can't really observe this on small things, but when two large objects collide with each other, they generate heat. The energy of movement that they have gets transformed into thermal energy. So that brings us to another scientific law. Conservation of energy. In a chemical reaction, in just moving junk around, energy is neither created nor destroyed. Energy can change from one form to another. It can go from potential energy to kinetic energy to thermal energy. You can transfer energy from one object to another. Thermal energy will flow from the warmer object to the cooler object. But the total quantity of energy is constant. Another idea that's important is that objects with high potential energy tend to be unstable, just like that lost the word, 10 kilogram weight sitting on the top of the building. It's unstable. You give it a nudge, it'll fall off. Once it's sitting on the ground, if you give it a similar nudge, will it fall down 2 stories? No, there's nothing for it to fall off of. You can't fall off of the ground. And it's not going to suddenly fall up because that would be against the law of gravity, and you can't do that. Another kind of energy that's important in chemistry especially is chemical potential energy. This is a form of potential energy. And this is a potential energy that arises not from the position that it's elevated above the ground, but it has to do with how the particles are arranged within it. So this is the potential energy due to composition. Atoms are made up of charged particles, and they interact with each other. And the interactions between those particles can cause that substance to be stable or unstable, to have high potential energy or to have low potential energy. Think about gasoline. Gasoline is unstable. We have to treat it with care because, you spill gasoline on the floor and there's a spark, all the gasoline in the air is going to combust. And it's potentially very dangerous. Gasoline has high chemical energy because of how the particles are arranged. So you can put gasoline into the engine of your car and it gets fed, not into the engine, you put it in the gas tank. It gets fed into the engine where it combusts under a controlled environment, and that chemical potential energy gets transferred into kinetic energy of the pistons, which then causes the drivetrain to rotate and causes the wheels to move and your car goes forward. You've taken chemical potential energy in the gasoline and you've changed it into, transformed it into kinetic energy of your car. So systems with high potential energy tend to change in a way that lowers their potential energy. So after that combustion, the molecules in the exhaust, could you take those and put them back in your gas tank and burn them again? No, because they have a much lower chemical potential energy. They are stable, they're not really going to do anything. The potential energy that was stored in them has been released into your engine. Now, energy is conserved. What happens here is we've taken that chemical energy, we've turned it into kinetic energy. What happens to your engine after it's been running for a little bit? Do you want to just stick your hand on there? Why not? It gets hot. So we have the radiator and the cooling system to cool it down. What often happens when we transform energy from one form to another is that we also have some, we say it's lost, it's not really lost. So that chemical potential energy was transformed into kinetic energy, but also some of it went into thermal energy. The thermal energy often just kind of dissipates into the atmosphere. We say it's lost because it's not useful. And so there's an efficiency. You can't just transform one source of energy into another and back and just go around and around. Every time you change the form, you lose a little bit to thermal energy. And if your car is more efficient, then it loses less to heat than if it's not very efficient.